Well, on behalf of Fruit d'Or and Complete Phytochemical Solutions, we thank you again for coming this afternoon. We think we're going to be able to share some information with you that's very relevant about what we're passionate about, which is making people well, and doing that in a way that is based on good foundational nutrition, whole food nutrition, and also to do it in a way that's clinically validated and reproducible and verifiable. So that's something that quality dietary supplement and food companies are interested in. So we thank you for coming. So we're very pleased to have Christian Krueger speak to us today. He's done some extensive work in the area of analytical chemistry on cranberry and its phenolics and specifically proanthocyanidin components. And then we'll hear a brief overview from Stephen Lukawski about Fruit d'Or Nutraceuticals and the work that they are doing to provide high quality materials in this area. So we're going to hear a little bit about Fruit d'Or Nutraceuticals from Stephen, and then he will then introduce Christian. So thank you once again.
Good afternoon, everybody. Thank you for coming to the Cranberry Educational Seminar sponsored by Fruit d'Or Nutraceuticals. I don't know if anybody is familiar with Fruit d'Or, but the company has been around since 2000. We got over 3,000 acre farm. We have over 33 growers involved in our company, and we produce about 30,000 tons a year. We're the world's largest organic cranberry and blueberry company in the world. We're the fastest growing company in Quebec, Canada. We have over 200 employees, and we've been around since 2000. We have distribution to over 50 countries worldwide, and we're always looking to grow our business. Fruit d'Or has been involved in the food and beverage industry, so when you see sweet and dried cranberries, and you see beverages like what we have on the back table for you outside, this is how we built our business. Now we're getting into the nutraceutical, all-natural cranberry powders, but we're now going beyond urinary tract infections. We respect the cranberry from seed to table. We're vertically integrated. We're GMP, so we harvest, process, and we sell to retail. So basically, we're really about pure, clean, natural, whole food. Pesticides, heavy metals, and no additives is really our importance of separating ourselves from the rest of the cranberry suppliers out there in the industry who are in the all-natural cranberry business. We're organic, we're certified, non-GMO verified. This is the future, it's here and now, and we're preparing for that as we move forward to selling our nutraceutical ingredients. We're committed to research, science, standardization, and efficacy. This is why we are all here and why this seminar is so important as the beginning of the future for the cranberry industry as we move forward in the area of standardization. What makes Fruit d'Or different? Again, organic, quality supply. We're all about sustainability, our process, and our innovation. So I'm just going to go through this quickly, and then I'm going to bring on Christian. We raise the bar to a higher standard. In other words, there's no standards really in the all-natural cranberry industry right now. There's no efficacy on the labels for standardization of what you're actually buying. So we're worldwide certified, and we're a worldwide leader in organic cranberries and blueberries. Traceability from seed to retail, transparency, quality control. We have an agronomist on staff. We're all about food safety. Our policies are established at a higher level, and we're kosher, we're halal. We look for long-term partnerships directly with our growers and our customers. We're not in the business of selling cranberry. We're in the business of growing our business one customer at a time, building partnerships. We have a team of 30 plus growers, and we provide a delivery just in time for your services as we grow. We work with only the best cranberries that we find on the market that we grow, right? So we select only the highest quality cranberries grown, and we're all about allergen, gluten, GMO free in our facility. We have a sustainable development policy. We use a biomass system and a reduction of water consumption. We're committed to research, science. We're a solution provider for all your cranberry needs. We develop new product opportunities beyond UTI, such as gut health, oral health, heart health, and cosmetic skincare and sports nutrition side. We offer the whole cranberry powder, seed protein powder, fiber powder, cranberry seed oil, and we also into tea cuts. One of our customers is Twin Lab, and they have the Altiva line. When I say beyond UTI, these are the areas of opportunities for growth for your company and for your business to be able to promote cranberry beyond traditional use of urinary tract infection. We believe that we can actually have enough preclinical evidence to basically prevent urinary tract infections through the gut rather than treat them. So this is what Christian is going to be talking about as we move forward. Oral health care, one person every hour dies, 24 hours, every day of oral cancer. This is an area of opportunity for the cranberry. The cosmetic health beauty market for the cranberry seed oil, very high in tocotrienols, so ideal for skin care. The baking industry, the seed powder from the cranberry is ideal with fiber and protein. The beverage market, again, another explosive growth opportunity for the seed powder as a source of protein and high in fiber. The sports supplement market, as you see, that market continues to grow. We're all about different delivery systems. What you have in your hand right now is a company called PNP Pharmaceuticals who actually was able to take the cranberry powder that we have, which is whole food, non-GMO, no excipients, no fillers, no lubricating agents. This is pure 100% cranberry. There is not anything like this in the marketplace right now. We've been able to do this, and this is a milestone for the cranberry industry, to have something as purified, that Mother Nature intended. Again, it's all about full spectrum, all natural. We're looking at stick packs and soft chews. We're looking at toothpaste, effervescents, sachets, gummies, oral film strips. These are new delivery systems because we really believe it's not about how much you take, it's about what you absorb. And we'll be talking about the milligrams of proanthocyanidins that we feel is very important in moving forward to talk about standardization. We're going to be going through these, but not through my presentation, but through Christian's. We've tested 5 different manufacturers, suppliers of cranberry. All right, and we did all our testing based upon Christian Krueger's new analytical tools and methodologies. And these are now the new tools that are presenting itself in the market to be able to do a fingerprint thumb analysis of the cranberry. So you actually know what your starting raw material is when you go to do research. No one in the industry has done this. And this is why all the past science out there that's been done on natural cranberry products are suspect, only because no one ever established that what was inside that cranberry to begin with. So we're all about preventing manipulation and adulteration and moving forward with efficacy and standardization. I'm not naming any of the companies that we manufacture. For those who would like a copy of this presentation, we'll disclose that at that point in time. But I can tell you, the leading brands out there, this is a great opportunity to listen to Christian Krueger, what he has to say, to be able to revisit and formulate with efficacy on the labels to generate more sales for yourselves. This is not about who's better than the rest. This is about separating ourselves from the lower end products in the marketplace that are taking up retail space. And we feel that there's an opportunity to create new formulations with the cranberry to generate more sales and profit for your company. I think at the end of the day, there's some takeaways that Christian's going to talk about, but we are all about milligrams of packs. This is what we want you to understand, that 36 milligrams of packs is equivalent to 8 to 10 ounces of cranberry juice without the sugars. And this is what we're delivering at Fruit'Or as we move forward to separate ourselves and grow the industry. So we're asking all the other cranberry companies to look at what we're doing and join forces with us, all right, in creating a higher quality standard and raising the bar. If you want to juice powders, that's fine, but understand that you may have to take 12 to 15 capsules a day to get the efficacy of 36 milligrams of packs. This is important because it's a game changer in the industry. I would like to welcome Christian Krueger to present his seminar.
Well, good afternoon, everybody, and thank you, Stephen, for inviting me here today. Stephen and I have a little competition to see who can wear the brightest colors in the room, and I think he's got me with the pants this time. So I think next time I'm going to have to do a little bit better. Just as a point of disclosure here before we get started today, the presentation materials that you see here are going to be a combination of the work that I've done in my position at Complete Phytochemical Solutions and work that I've done at the University of Wisconsin at Madison. At Madison, I'm the Director of Operations of a research program that focuses on phytochemistry and nutrition, and in our company setting, it's a focus on consulting and analytics services. Everything that's here today has either been published in scientific peer-reviewed journals or was done in cooperation with Fruit d'Or, and I have their permission then to share that information as well. So as we get started here, I think what Stephen kind of took us down the line here, really what we're focusing on is an educational campaign starting now. We've been working together for about 2 years. What we're trying to do is take a look at the analytic methods that are out there in the marketplace, what the new tools are that are available to the market itself, and help to navigate and educate folks all the way from the formulator to the consumer. So here's the situational overview of where we're going today. Some big ideas: authentication and standardization and efficacy evaluation. These are the words you're going to hear in the marketplace. How do we know this is an authentic material? Okay. How do we standardize this material? And how can we show that there's efficacy? How do we relate the specific compounds to an end result through specific mechanisms? And the tools are there. It's critical when we think about products to understand the whole cranberry composition in terms of an all-natural product. Many, many years ago, the products that were in the marketplace consisted of cranberry juice, changed over to spray-dried cranberry juice powder, and then we've gone now into a world that we're using whole fruits, residuals from the fruit juicing process like press cakes, seeds, oils. There's many, many things in these products beyond proanthocyanidins. So it's important to really think about what the product is composed of. Advanced tools, analytic tools, we're going to spend some time talking about those. They're available. We don't always have to go at the lowest end of analysis. There's things that can give us better information, and as players in the market, we should know what those tools are and how to use them. And then the last part here, just talking about new market opportunities. What is there out there, and where's the new opportunity to make money? You know, this is what this is about. It's bringing products from a discovery phase to the marketplace, and where are those new markets evolving? So I broke down today's presentation into 3 sections. I'm going to talk about cranberry polyphenol fingerprinting. This is analytics and method advancements that we've been working on over the last few years. We're going to talk a little bit about urinary tract health, and this is really a novel way of thinking about urinary tract health. And so I hope that the images and the results we can share here today are intriguing. And please, if there's questions, we have a small enough group, interrupt me. I'm going to try and leave enough time at the end to take questions as well. And then the last component will be focused on cranberry and gut health. And this is a new area that we're getting into that's pretty exciting. So when we think about the natural products, it's pretty easy to identify these products if you have a frame of reference. So most people would be able to identify the grapes and the blueberries. There's hops. Hops go into beer. We've got a nice stein of beer, a nice bottle, red wines. These are things, it's easy to tell what these products are. But now what happens if we take away that frame of reference and we're left with a powder or we're left with a capsule? How does the buyer, the formulator, or the end consumer make the right choice on how to purchase a quality cranberry product? Everything we talk about today is going to focus on cranberries, but certainly this is applicable to other food commodities such as blueberries and grapes and wines, and things of that nature. Well, the question is, what defines a cranberry? Okay, we have to know what our starting material looks like in order for us to be able to look at an end product and compare that back to the original. So we've conceptualized a process here by where we fingerprint a cranberry. Okay, cranberries have a unique characteristic to it, just like each of us do. We've all got our own fingerprint. So what is this fingerprint? What are the unique characteristics of a cranberry that we can trace through the process line? If we focus just on polyphenols, a small class of the total group of what makes up a cranberry, we've got 4 different subcomponents. Got a subcomponent called a flavonol, it's a monomer. Anthocyanins, these are the compounds that give the bright red color to the cranberry. We have hydroxycinnamic acids, and we have proanthocyanidins. Now, in the case of urinary tract health, the proanthocyanidins are the class of compounds that have gained the most attention. And so most of my talk today will be on the proanthocyanidin class. So you can already see that we've gone from a big picture, we've got fibers and proteins and polyphenols. We broke the polyphenols down into subclasses, and now I'm going to break down one of those subclasses into a sub-subclass. This is how we're taking apart a cranberry and understanding what it's made of. This fingerprint, the tools that we use here, can be used to authenticate cranberry materials. It can be used to standardize the materials, and it can be used in efficacy evaluation. This is going to be a constant theme that we're going to be talking about today. So let's talk about the methodology. This is the first section of the talk today. 4 main points that we'd like to touch on. Selection of an appropriate standard reference material. Okay. There's a method called a DMAC analysis. DMAC stands for dimethylaminocinnamaldehyde. For those that like science, they'll understand that. Those that don't like science will refer to it as a DMAC assay because we like acronyms. It's the same method. We're going to talk about that today and talk about how that method is used to quantify the soluble proanthocyanidins. Soluble meaning we can extract them away from the cranberry fruit itself. We're going to talk about the discovery and the quantification of insoluble proanthocyanidins. This is a class of proanthocyanidins that has an affinity for fiber and protein and remains with the press cake after juicing. And then the last thing we'll talk about today is MALDI-TOF mass spectrometry. MALDI stands for Matrix-Assisted Laser Desorption Ionization Time of Flight mass spectrometry. I like MALDI better. How can we use this tool to authenticate proanthocyanidins? Let's start with what a proanthocyanidin looks like. Here's the structure. Our friend Yip Fu back in 2000 isolated a trimeric proanthocyanidin from cranberry and performed structural elucidation using NMR and high-end instrumentation, and this is what it looks like. Proanthocyanidins are polymers. They're natural polymers. So when we look at this product, you can see 3 repeating units. The building blocks of proanthocyanidins are catechin. So there's a catechin monomer, dimer, and trimer. 3 of them together make a trimer. There's also different linkages that occur. The blue linkage is referred to as a B-type interflavan linkage, and the red linkage is an A-type. A-type interflavan linkages are very unique to cranberries. So there's another structural feature, another component of this fingerprint that we're going to pay attention to. So cranberry proanthocyanidins, as we talked about, can be broken down into 2 subclasses: soluble, extractable, and insoluble, that remains with fibrous materials. When we look at juices and spray-dried juice powders, the soluble packs are what are found in those products. They've been extracted during a juicing process. The packs got into solution. Now they may have been spray-dried or they may be in the cranberry juice itself. The insoluble packs can be found in the whole fruit, the press cake, and products like sweetened dried cranberries. It's in the middle there because it also contains soluble packs. So there's a hybrid there. So when we're talking about 2 different classes. One class has solubles, one class has solubles and insolubles. So we want to know what the whole picture looks like. Here's the importance. Quantitation. Question is, how much is there? Well, this is necessary for product uniformity, selection of raw ingredients, regulatory compliance, value-added differentiation in the marketplace, and customer satisfaction. Here's our method, dimethylaminocinnamaldehyde, DMAC. This is a colorimetric method, okay? And it measures only soluble packs. As we increase the amount of soluble packs in a sample, we have, under this reaction condition, the production of an increasing amount of a pigment. It's a bluish-green pigment, okay? So if we have a little bit, we kind of have this light blue at the bottom, and as we increase the amount in the product, we have a darker color. So this is referred to as a colorimetric reaction. It is not specific to cranberry proanthocyanidins. Grape proanthocyanidins will interact. Apple proanthocyanidins interact with this reagent. It is not a measure of authenticity. It is a measure that is being used for the quantitation of soluble packs. Here's a dimer, a proanthocyanidin dimer. 2 monomeric building blocks connected by a B-type linkage. Here's dimethylaminocinnamaldehyde. When we combine these two compounds, the dimethylaminocinnamaldehyde is able to interact with the C8 terminus of this dimer. It reacts once with a dimer. So there's one reactive group and there's 2 monomeric groups in the dimer. So out of the dimer, only one end can react. Okay? This is important because as we grow in polymer length, we have more and more unreacted groups associated with that. So in a trimer situation, you will have 1 reactive group and 2 unreactive groups. So we're adding weight to the compound, but no additional reactive capacity. So why is this important? It's important when we start to deal with what is a relevant and appropriate standard reference material. So if we were to do a comparison, and I'll show you the results in just a minute here, catechin is the monomeric building block. Procyanidin 2 and procyanidin B are dimeric polymers of catechin. Procyanidin A2 has been adopted by the cranberry industry, large part, as the standard reference material of choice. And then we went a little step further and produced a standard reference material of proanthocyanidins that were isolated from cranberries and are reflective of the polymeric dispersity that's in cranberries. Okay, so again, the catechin is the monomer, the procyanidin 2 is the dimer, and when we refer to the CPAC standard, this is a distribution from dimers out to and including 30mers. So this is a big polymer distribution. It's a very complex standard reference material, but it's reflective of what's present in the cranberry. And here's the results. On our x-axis here, we see the mass of the standard reference materials. On the y-axis, we see the absorbance. And what's happening as you increase mass, you increase the absorbance in the DMAC reaction. Okay? If there was no difference between the choice of standard reference materials, all 4 of these curves would overlay each other, right on top of one another. But there is a difference. Okay? And the difference is the smaller molecular weight has a steeper slope than the dimer. And the dimer and the monomer have a steeper slope than the complex polymer. Again, if we remember why this is, each time we add an additional unit of polymer length, we don't add another unit of reactivity. Okay? Interestingly, the A2 dimer and the B2 dimer are the same. That should be expected. That interflavan linkage is not influencing the reactive kinetics of this reaction, only the polymer length. Okay? So what does this mean? It means that the use of an A2 dimer is underestimating the total proanthocyanidin soluble component of products. Okay? If we use an A2 dimer to quantify soluble packs and compare that to the CPAC standard, you can see maybe it's difficult here, but I put a little circle around there in green. In the case of the A2, our highest bar is 9 milligrams per gram. When we use an alternative standard, we're up to 30 milligrams per gram. Okay? This isn't just tampering with numbers to get higher values. This is improving the accuracy and the precision of this method. Okay? When we do an analysis, we provide both of these numbers. Again, the A2 is the industry-adopted standard reference material. What we're trying to do is educate the industry at large that there is an improved standard reference that can be used, that gives you a better understanding of compositional information of your products. Okay? And it's going to take time for people to understand what this all means and how it's going to be adopted. So in the interim, you'll see these two numbers, and I think in all of Stephen's products and spec sheets, both of those numbers are presented. And that's part of this educational aspect. I'm going to move on to a second topic here now, insoluble proanthocyanidins. These are the proanthocyanidins that remain with the fibrous material after extraction. Okay? They're bound to fiber. So they are not released during a juicing process. They are not released during the DMAC extraction process. They sit with the fiber. There is the capability now of starting to quantify what sits with the fiber. So what we do is after the extraction process, after we run our DMAC, we're left with a residual material, and we dry that. We take that dried residual material and we put it in a butanol hydrochloric acid solution. And what happens after you heat that solution is it turns red. This is an auto-oxidation reaction where the anthocyanins are cleaved and produce a red pigmentation. So under these conditions, you can start to cleave and break down this proanthocyanidin that's attached to the fiber and release and produce a red color. In the same manner as the DMAC assay, the red pigment is indicative of how much material is there. The more red, the more material. Again, with the same Cranberry standard reference material, we can produce a standard reference curve and quantify the amount of proanthocyanidins that are insoluble or associated with the fibrous material. That's represented here. If we combine those two numbers together, we have a representation of total proanthocyanidins, soluble and insoluble. Yes, we use two different methodologies, but we now have a better handle on what that class of compounds is in a Cranberry product, in a fresh fruit, in a powder, in an all-organic material. This is a real advancement. This method has been around, this butanol HCl method has been around for a long time, and it historically found its use in forage analysis. Okay. Up until this point, it has not been deployed in the world of the Cranberry. Okay? So we've took basically what was out there in the literature, we understood the chemistry, and we said, this has application in the field of Cranberry if we have a relevant standard reference material to quantify it. The last aspect here now of the analytics is the method of MALDI-TOF. And this is a really neat, powerful mass spectrometry tool for looking at polymer chemistry. Real briefly, what we do is we take the analyte, the Cranberry sample, we mix it with a matrix, and we put it on a stainless steel target. And then we shoot it with a laser. And the matrix is absorbing the energy of the laser, and the analyte desorbs off the target and ionizes. So desorption, ionization. And then it travels down a vacuum tube. The smaller the molecule, the quicker it travels. So you're having an in-tube separation. This is a real-time separation. These things are happening in nanoseconds. This is a very, very rapid and quick process. But it does allow you to do polymer chemistry with mass spectrometry. And I could talk at least for an hour on that aspect alone, but we're going to condense it down to one slide. This is the take-home message. The interflavan linkage, as we talked about earlier, there's an A-type linkage and a B-type linkage. The A-type linkage is very unique to cranberries. So when we look at a mass spectra, our x-axis here is mass, and our y-axis is charge. What we see are a number of peaks. These correspond to the isotopes of a pentamer in this case. So that's 5 degrees of polymerization. What I have labeled here as 2 atomic mass unit differences are the differences in the number of interflavan linkages seen in that pentamer. Okay? So in the case here with the mass 1575, that would be a pentamer with 4 B-type interflavan linkages. The mass 2 lower is a pentamer with 3 B-type linkages and 1 A-type linkage. The mass 2 lower, 2 A-type linkages, 2 B-type linkages. This is the power of this analytic tool. We have unit mass resolution, and we can quantify the relative proportions of these interflavan linkages. Right there is what we're looking at. Okay, what does that mean in the take-home? If we have our Cranberry proanthocyanidin standard reference material and produce a mass spectrometry profile of that, we can use matrix algebra, and there's a nice publication out there that'll put you to sleep at the end of the night that's going to tell you exactly how to do this. We can use that to look at the relative proportions of A-type to B-type interflavan linkages in Cranberry products. We did the same thing with apple proanthocyanidin standard reference material. The take-home is that apples have primarily all B-type interflavan linkages, as indicated by the purple, a little bit of A-type interflavan linkage, where on the other hand, Cranberry has a very small proportion of all B-type linkages, and the majority of those linkages have 1 or more A-type interflavans. Take-home is, picture on the right, on your left is Cranberry, picture on the right here is apple. If I get a novel sample and I run mass spectrometry on this and do my deep convolution and it looks like that, it's adulterated. Okay? This is the test for adulteration. This is a very, very powerful tool. So what's the take-home message here? We've developed a superior standard reference material. Is it the best? Is it the final standard reference? No. We're going to get better. We're going to keep working on this. But it's an improvement over the A2 standard reference material. The application of that then in the DMAC assay allows us to better quantify more accurately and more precisely the amount of soluble proanthocyanidins in products. It can also be used in the insoluble method of the butanol HCl to quantify insoluble packs. The MALDI-TOF mass spectrometry is used for authentication of Cranberry materials, and collectively, these tools can be added together with other tools such as HPLC, colorimetric reactions, to quantify the total polyphenolics of cranberries. And we didn't touch on any of those today just because of time. We'll talk real briefly here now, probably about 4 slides worth, of cranberry and urinary tract health. Here's some important things that aren't typically pointed out. Okay. Greater than 95% of the proanthocyanidins that enter the oral cavity never leave the intestinal system. They're excreted in the feces. Okay? But yet, there's a relationship between the consumption of these compounds and urinary tract health. Okay? There's a lot of folks out there right now trying to track down what is absorbed. They're looking in blood, they're looking in urine, they're looking in the bladder for these compounds. That would tell us that these things are having the site, the active site is in the bladder itself or in the urogenital tract. We said, let's take a look at this a little bit differently. We know where the majority of these compounds are. They're in the lumen of the intestine. So let's pay attention there as to what's going on. The novel mechanism, we believe these proanthocyanidins are having an effect at the gut level in modulating the colonization of the intestinal tract by uropathogenic E. coli. Here's some nice scanning electron micrographs of uropathogenic E. coli. These pathogens adhere to the epithelial cell surface. They actually hijack the cytoskeleton of that cell and can invade the cell where they set up residence. They can evade detection by the immune system. They're hiding in the cells of the intestine. They can set up a transient but persistent colonization. Okay? So what did we do? We took a product, we took the proanthocyanidins from that product, and we said, let's build a model system. Let's take a cell culture system. We're going to make a monolayer. We're going to make some Keiko-2 cells, gut epithelial cells, and we're going to put a layer down. We're going to challenge those with uropathogenic E. coli. And we're going to look and see how many of those uropathogenic E. coli actually invade that epithelial cell. Okay? Then we're going to put some different levels of Cranberry proanthocyanidins in there. And we're going to see if we can prevent that invasion from happening. This is a relevant model because the Keiko-2s are epithelial cells, intestinal epithelial cells. Our proanthocyanidins come in contact with them just like they would in the lumen of the intestine. The bacteria can come in contact just like the lumen of the intestine. So we're in the right region, and we're designing this in such a way to be able to look at physiologically relevant doses. Okay, so when we look at our x-axis down here, we're at a high dose of 90 micrograms of Cranberry proanthocyanidins per milliliter. That's comparable to drinking 1 glass of cranberry juice. Okay, that is physiologically relevant. What do we see? At our high dose, we have a significant reduction, in this case, close to 20%, or I should say 80% reduction in the number of uropathogenic E. coli that actually invade the cells. Okay? If we reduce invasion, we reduce the population of uropathogenic E. coli in the intestine. Here's a picture of what's happening. On the left panel, the control, uropathogenic E. coli. In the middle, we add Cranberry proanthocyanidins. You can see how those bacteria are starting to be cross-linked. These proanthocyanidins, by their nature and by their definition, bind proteins. Bacteria have proteins. They have cell wall constituents. These things are getting tied up. If they're tied up and can't gain access to the epithelial cells, they're going to get washed through the system. They're not going to be able to set up a transient and persistent colonization. Okay, here's a close-up. So what does that mean? If they can't set up residence in the intestine, it's a lot more likely they're not going to cause a problem in the urinary tract. So here's a mechanism where we can take a prophylactic approach to modulating urinary tract health. Okay, this is not a therapeutic mindset. This is, let's take care of these guys before they set up a residency, migrate down and up the uroepithelial tract and cause a problem. Different way of looking at it, same outcome, cranberries and urinary tract health, just looking at a different world. Last topic today, gut health. There's a little quote from, a few thousand years ago. All diseases begin in the gut. It's true today as it was then. And most of it's focused on immune deregulation, which is central to most gastrointestinal disorders. More than 34 million Americans are affected, and 20 million have a chronic problem. Okay? These can consist of ulcers, inflammatory bowel disease, Crohn's disease, GI cancers. It accounts for 8 to 9% of the total U.S. mortality, and the economic cost is estimated at $50 billion annually. That's a market that I'd want to play in. Let's talk a little bit about the gut and how we're approaching this. The gut immune system and the microbiota are working together to modulate our system. When we think about the microbiota, we have commensal bacteria, the good bacteria, and we have pathogenic bacteria, such as the uropathogenic bacteria. Diet has a huge impact on both of these aspects. Diet complexity and diet composition are two key players that modulate both systemic immunity and infections. There's a number of roles and routes of nutrition. Most of us think about consuming whole food by the mouth. If we're compromised, say in a trauma event, we would be given a gastrointestinal tube or an IV, where our diet is very simplified. It's elemental nutrition. It's peptides, it's amino acids, and it's sugar, and minerals, and vitamins, and that's it. No complexity. If you have an elemental diet, you're more susceptible to diseases because your gut starts to atrophy. Okay? We conducted a very small trial here, very quick. It was an animal study, a mouse study. We gave the mouse elemental enteral nutrition, gave them a regular chow, a regular food diet, and then we gave them 3 different doses of cranberry proanthocyanidins, as was characterized by the mass spectrometry earlier, in addition to the EEN solution, the elemental enteral nutrition. And we wanted to see what would happen. Here's the key players we're looking at. 2 cytokines, IL-4 and IL-13, that positively reinforce the production of mucin by goblet cells and positively reinforce the excretion of secretory phospholipase by Paneth cells. These are 2 things that aid in typical barrier function and immune regulation. So what do we see? In the chow diet, the non-purified diet, when we go to the enteral diet, we see a reduction in IL-4. And with the subsequent addition of the cranberry packs, this is the only complexity that's being added to the diet, are the proanthocyanidins. Remember, they're not being absorbed, so these are having a gut level effect. We restore IL-4 back to its original condition. Same with IL-13. Okay? These are the 2 cytokines that are regulating mucus production for barrier function and SPLA2 excretion. Here's our mucus production. Again, increased with the addition of packs. I don't know if we can see this too well, but this is SPLA2 expression. Again, in the EEN solution, very low. As we go out here and add more packs, we come back to the chow situation. What's the take-home message? It's the last message of the day, because Tim's here ready to kick me out. The gut immune system plays a critical role in systematic immunity. Okay. Things that happen at the gut can influence the whole body. Okay. Something as simple as adding a non-absorbable class of compounds, the proanthocyanidins, to an elemental enteral nutrition improves gut health and systemic immunity. Okay. This is really neat. That we're looking at gut level functions of a class of compounds that till now have been pretty much systematically ignored in terms of the role they play in health and nutrition at this level. So this is really kind of where we see the future and the future opportunities coming. I thank you for your time and your patience. Again, I was probably a little bit long-winded, and hopefully I've got a few minutes for questions here today, and I appreciate the opportunity.
Thank you, Christian. So we do have 5 minutes. We want to be respectful of those following us, but maybe we'll start on this side, maybe for one question, then we'll look to that side. We have 5 minutes. Yes. So the question was difficulty of using the FC method, which is for total phenolics, in quantification and establishing quality of materials.
So this is really important. The only methodology out there right now that is capable of distinguishing A-type linkages from B-type linkages is a mass spectrometry-based technology. Okay, my preferred method is MALDI-TOF because it's very well suited for heterogeneous polymers. The same can be applied. Electrospray ionization mass spectrometry can be used. It's a more complicated mass spectral interpretation, but it can be used. Other methods, the colorimetric methods, will not give you that information. HPLC analysis by diode array detection will not give you that information. NMR, if you're an expert and know how to interpret it, you might be able to get that information, but you're talking very, very high-end and very, very difficult analysis at that point. Stephen's asking me about the Europharma method for quantification. That falls into the same realm as the DMAC and the Folin-Chakato and the butanol HCl method. It's a colorimetric reaction, and it will not give you the authentic nature of that interflavan linkage. So the question is, has there been any clinical studies performed with this particular extraction, this proanthocyanidin preparation? This particular proanthocyanidin preparation that was used in the mouse studies and for all of the standard materials is all produced currently at a lab scale process. So we have not taken up the production to a level yet that we can take it into a clinical setting. So the strategy moving forward would be to partner with an industry group that's capable of producing a large enough quantity of materials. It doesn't have to be purified proanthocyanidins. It just has to be a well-characterized product. Then we can go to the marketplace and correlate then that compositional information to the whole outcome. So the question again is, are there any health benefits that are specifically related with bigger polymer size of the proanthocyanidins? What I can tell you from my experience in looking at proanthocyanidins, in all of our cell culture work, the bigger the polymer size, the more effective it is at the same dose. So in this case, we looked at the polymer distribution, probably from dimers up through 30 mers. If we were to take that and narrow it down into small molecular weight, mid molecular weight, and large molecular weight, the large molecular weight at that same dose would be much more effective. So again, by their nature, proanthocyanidins bind proteins. And if you think about the bigger these things are, the more they can interact with the environment and the proteins in that environment. So it's our experience that bigger polymers are more effective, which is great because the bigger the polymer, the more likely it's going to stay in the intestine. So the question is, how do the anthocyanins, the red pigments, react in the butanol HCl assay for the quantification of insoluble packs? And the answer is anthocyanins will not react in that, but they will add color. So if you had an extract, a cranberry extract, before we conduct the butanol HCl reaction, the heating process, we heat it at 100 degrees for an hour, we would use that solution as a blank or as a zero. So the contribution of that anthocyanin to it would be eliminated. We'd negligate that aspect. The question Stephen has is, does cranberry juice powder have insoluble packs? This is a difficult question. The cranberry juice powder by itself probably does not have insoluble packs, but the effects of processing, so spray drying, adding nucleating agents, adding flow agents, can create insoluble complexes. So the packs themselves can interact with other carriers during that process and actually be converted from soluble to insoluble. Heat is a big converter, so very hot processes can convert from soluble to insoluble packs.